Today is a beautiful day for science. This first filter is Angstrom 94 and is designed to study solar flares. It measures extremely hot temperatures around 6 million degrees Kelvin, 10.8 million degrees Fahrenheit, and shows the flaring regions of the corona. The primary ions seen here are 17 times ionized iron. This filter's Angstrom 131 is designed to study solar flares. It measures extremely hot temperatures around 10 million degrees Kelvin, 18 million degrees Fahrenheit, as well as cool plasmas around 400,000 degrees Kelvin, 720,000 degrees Fahrenheit, and shows flaring regions of the corona. Primary ions seen here is 20 and 7 times ionized iron. This filter is Angstrom 171 and is especially good at showing coronal loops, the arcs extending off the sun where the plasma moves along the magnetic field lines. The brightest spots here are the locations where the magnetic field near the surface is exceptionally strong. This shows the quiet corona and upper transition areas at approximately 1 million degrees Kelvin, 1.8 million degrees Fahrenheit. The primary ion seen here is 8 times ionized iron. This filter is Angstrom 193. It highlights the outer atmosphere of the sun, called the corona, as well as the hot flare plasma. Hot active regions, solar flares, and corona mass ejections will appear bright here. The dark areas, called corona holes, are places where little radiation is emitted, yet the main source of solar wind particles. This filter shows the corona and solar hot flare plasma at 1.25 million degrees Kelvin, 2.25 million degrees Fahrenheit. The primary ions here are 11 times ionized iron. This filter's Angstrom 211 highlights the active regions of the outer atmosphere of the sun, the corona, and the active regions solar flares. The corona mass ejections will appear bright here. The dark areas, once again, are the corona holes and are places that have very little radiation emitted, yet the main source of solar wind particles. This shows the active regions of the corona at 2 million degrees Kelvin, 3.6 million degrees Fahrenheit. The primary ion seen here is 13 times ionized iron. This filter is Angstrom 304. It is especially good at showing the areas where the cooler, dense plumes of plasma, filaments and prominences is what they are located above the visible surface of the sun. Many of these features either cannot be seen or appear as dark lines in the other angstroms. The bright areas show places where the plasma has a high density. Overall, this shows the chromosphere and the lower transition region at 50,000 degrees Kelvin, 90,000 degrees Fahrenheit. The primary ions seen here, singly ionized helium. This is filter 335. Angstrom 335 highlights the active region of the outer atmosphere of the sun, the corona. Active regions, solar flares, and corona mass ejections will appear brighter here, and the dark areas, or corona holes, are places where very little radiation is emitted, yet are the main source of solar wind particles. This shows active regions of the corona at 2.8 million degrees Kelvin, 5 million degrees Fahrenheit. The primary ions seen here are 15 times ionized iron. This filter's Angstrom 1600 often shows web-like patterns in bright areas that highlight places where bundles of magnetic field lines are concentrated. However, small areas with lots of field lines will appear black, usually near sunspots and active regions. This shows the transition region and upper photosphere at 6,000 degrees Kelvin, 11,000 degrees Fahrenheit, and 100,000 degrees Kelvin and 180,000 degrees Fahrenheit. The primary ions seen here are thrice ionized carbon and continuum. This filter is Angstrom 1700. often shows, again, web-like patterns and bright areas and highlights places where the bundles of magnetic field lines are concentrated at 6,000 degrees Kelvin, 11,000 degrees Fahrenheit. However, small areas with a lot of field lines and will appear black, usually near sunspots, active regions. The primary ion shown here is continuum. This is the HMIBC. This shows the polarity of the areas on the ground for the active regions. The light yellow and red signify the negative, yellow being weak negative, red being strong negative, and the blue and green being the weak positive, and dark or blue being the strong positive, to see where the polarity is for the regions that are active. Cheers and science on.